So what is kinematics?
What is what?
Kinematics.
I don't know.
Want to give it a guess?
Kinematics. Something about the study of Earth gravity.
What is what?
Okay.
Kinematics?
Bring 'em on there.
Kinematics?
Yeah.
No idea.
Do you have a guess?
Something to do with kinetic energy?
Alright, what is kinematics?
Okay, I'm out.
I'm out also. I don't know.
Do you have a guess?
I have no clue.
Do you have an educated...
In my educated guess, and I really don't know what it is, but maybe it has something to do with kinetic energy since it's kina, and matics is maybe, I don't know, how kinetic energy is stored and applied to potential energy. That's all I got.
That's really
I'm
good.
a paramedic and fireman, not a physicist, but that's a shot.
Good day, class. Today we'll be looking at the equation v final squared equals v initial squared plus 2a times delta x. So, where does this equation come from? Well, if we start with the equation v final equals v initial plus acceleration times time, and then if we proceed to square both sides of the equation and then expand said equation, the result is v final squared equals v initial squared plus 2 times v initial times acceleration times time plus acceleration squared times time squared. Now, by working some algebra karate, we can pull out a 2a from the end of the equation. Now, many of you might be thinking, hey, the last part of the equation kind of looks like the equation for delta x. Well, my friends, you are right. So by rewriting the equation, we end up with what we started with. V final squared equals v initial squared plus 2a times delta x. In the previous example, Reed hikes a handball. The ball flies through the air on a parabolic path and reaches its apex, or highest point, in the middle of the flight. To solve this, you first want to break up the velocity into its components. There is the y direction and the x direction. However, for this problem, you will only need the y component, because we are simply solving for delta x in the y direction. We will say that the initial velocity was 6 meters per second. So v initial in the y direction is 6 times sine 60 meters per second. V final in the y direction will be 0, because at the top of the parabola, it is 0. Also, acceleration will be a constant negative 9.8 meters per second squared, due to gravity. Now, calculate the height for delta x in the y direction. First, start with our equation. V final squared equals v initial squared plus 2a times delta x. Now, plug in the variables you know. 0 squared equals 6 times sine 60 squared plus 2 times negative 9.8 times delta x in the y. So simplify and you have 0 equals 27 plus negative 19.6 times delta x in the y. Bring the 27 over to the other side of the equation, and then divide out the negative 19.6, and the result is delta x in the y is 1.378 meters. In this problem, we will be looking at the motion of the red car, aka Lightning McQueen. Because the car started at rest, the V initial is 0 miles per hour. The V final is 100 miles per hour. The distance the car traveled, or delta x, was 0.25 miles. Now, we will calculate the acceleration of the car. Begin with the equation V final squared equals V initial squared plus 2a times delta x. Plug in your known variables so that 100 squared equals 0 squared plus 2 times acceleration times 0.25. Now simplify the equation so that 10,000 equals 0 plus 0.5 times acceleration. Divide out the 0.5 and the acceleration of the car is 20,000 miles per hour squared. Wow, that's fast! In our last and final example, yay! Caitlin throws a cow, a stuffed cow that is, straight up into the air. We know that V final is 0 meters per second when the cow is at the top of its flight. We also know that the cow traveled 2 meters from its initial starting position to its max height. The acceleration of the cow is a constant negative 9.8 meters per second squared due to gravity. Now we want to calculate V initial. Begin with the equation V final squared equals V initial squared plus 2 times acceleration times delta x. Plug in your knowns so that 0 squared equals V initial squared plus 2 times negative 9.8 times 2. Simplify the equation and get 0 is equal to V initial squared plus negative 39.2. Move the negative 39.2 to the other side of the equation and take the square root of both sides of the equation. The result is V initial equals 6.261 meters per second.